A very good morning, everyone. Today, we are going to have our in detail discussion in block diagram representation using direct form 1 and direct form 2 realization. So, whatever the problems that we had covered previously was directly where a differential equation or a difference equation was given, and later on, you would be able to realize it either in direct form 1 or in direct form 2 or both of them being asked. So in today's class, we are going to have a bit of reverse approach here. So what do I mean by reverse approach? So once the block diagram is being given, so you have to identify what is the difference equation of it. So we are going to have this reversal approach in today's class. So let me share my screen now. Yes. So I hope the screen is visible to everyone. Yes. So the question goes like this: Find find the difference equation. Find the difference equation. Find the difference equation corresponding to the corresponding to the to the block diagram to the block diagram shown in the figure below. Shown in the figure below. Shown in the figure below. Right. So the block diagram goes this way. So it's a difference equation. You are going to have a delay block. What you need to do is you need to write the sketch. I mean, it's already given in the question. What you can do is you can rewrite the same thing, and you have a summer block here, sigma. What it does, this is summed up. Yes. Okay. So this is two delay blocks at the input. Now this one is the output W of n. Next one, what you are going to have is another summation block like this. So from the output, that is y of n. Y of n. So you can take z inverse. Next, you can take another z inverse, the delay block, and you can take one more. Okay. So after 3 delays, you are going to have a scalar multiplier as 1/3. Okay. So this is the scalar multiplier. Next one, you are going to have minus 1/2. Yes. So this is the output here. Yes. So this is the given block diagram. Okay. So this is the given block diagram. Looking at the block diagram, I think you can come to know that it is direct form 1 realization. Direct form 1 realization. Okay. So looking at the block diagram itself, you can come to a conclusion that it is a direct form 1 realization. So what we can do here in direct form 1 realization is, so we'll count the number of delay blocks. So that is total number of delay blocks is 5. Number of delay blocks that is equal to m plus n, that is equal to 5. Okay, so that is the total number of delay blocks which are there, and carefully I'm going to write the output here. Okay, so carefully I'm going to write the output. So step one, what I'm going to do, I'm going to have W of n. So in order to find W of n, so what you are going to do, so you need to have this output here. So this is W of n. So in order to find that, you are going to have the summation of two inputs. So if you can clearly observe here, so x of n is one of the inputs. So x of n comes here. So x of n, okay, plus what you are going to have? So here it is going to be x of n minus 1. So here it would be x of n minus 2. So plus x of n minus 2 is there. Okay, so it passes through a amplitude multiplier, that is multiplication block. This is multiplication block, that is 2 times x of n minus 2. 2 times x of n minus 2. So that is w of n. W of n would be x of n plus 2 times x of n minus 2. Okay, so that is w of n here. So let me write down here. So after carefully analyzing the subsystem 1, I can write it as subsystem 1. So it can be written as, can be written as so w of n, that would be equal to x of n plus 2 times x of n minus 2. 2 times x of n minus 2, that is w of n. Next one, I have this subsystem being realized now. So this is subsystem 1. So next you are going to have subsystem 2 here. This is subsystem 2. So this is subsystem 2. So in order to realize the subsystem 2, what you are going to do? So you are going to have the first delay block, that is y of n minus 1. This one here is y of n minus 2, and this one here is y of n minus 3. Okay, so what you are going to do? Y of n minus 1, that is minus half into y of n minus 1. So here minus half into y of n minus 1. So here you are going to have 1/3 of y of n minus 3. Okay, so the output at the third delay block would be 1/3 of y of n minus 3. So all these things get added up to have y of n. So what you will get? Y of n, that is step number 2. Step number 2, what you are going to get? You are going to get y of n as w of n plus the first one, which is z inverse, as it is delayed by one block. So minus half y of n minus 1. Minus half y of n minus 1. Next, what you are going to have it? So you are going to have, after one delay block, one more delay block, you are going to have y of n minus 2. So you don't have any scalar multiplier here, or it is not connected to any of the sub system, or it is not connected to the summer here, right? So next you are having one more delay block, that is z inverse, and you are going to multiply it by 1/3 of it to get 1/3 plus 1/3 y of n minus 3. You are going to get it like that. So w of n minus 1/2 y of n minus 1 plus 1/3 y of n minus 3. So that is y of n. Okay, so now replace w of n with what you can replace? You can replace w of n with x of n plus 2 times x of n minus 2. X of n plus 2 times x of n minus 2 minus 1/2 y of n minus 1 plus 1/3 y of n minus 3. So that is y of n. So I can rewrite the equation. I can have y terms at the one end and the x terms at the other end. That is input signal on one end and the delayed block, which is associated with both input and output signal, right? So this I can write it as y of n plus 1/2 y of n minus 1 minus 1/3 y of n minus 3. That would be equal to x of n plus 2 times x of n minus 2. So this would be the total difference equation. Sorry, this is the difference equation. So you can rework it backwards, and you can definitely find the delay block which are being replaced, and you will be getting the same block diagram. Okay, so this is one of the given approach where the block diagram will be given. Okay, with the block diagram being given, and you have to find out the difference equation. Okay, so in the same manner you can have the differential equation also being written. Let me take one more problem in a similar manner. Find, I think second problem, yes. Find the difference equation. Find the difference equation. Find the difference equation corresponding to the block diagram. Corresponding to the block diagram. To the block diagram. Corresponding to the block diagram represented in the figure below. Represented in the figure below. Represented in the figure below. Okay, so let me write down the block diagram. So this is the summer, and you are going to have a delay block like this, and you are going to have the one more summer. Just before the summer, you have another scalar multiplier where you are going to have minus 1 by 4 in the block written, and input is x of n, and this one over here, it is being coming back, and it is plus. Okay, this is plus here. Fine. So next, what you are going to do, this is one more summer which is there. This you are going to have z inverse, and this one is y of n. Next, from y of n, you are going to have yes, like this. Next, you are going to have a summer like this. Okay, so this is the block diagram whatever I have represented, and here what you can see carefully is you are going to have the output being tapped from one of the signals there, right? So that is one thing which you can observe quite clearly. Okay, so one thing what you can observe quite clearly is this one. You can have a function like this, say omega n. Okay, so this is a function where you can have that is written, or you can have any other value which you can write it, or you can just have any signal which goes here, that is any value, and this one would be a of n minus 1. A of n I have written, so this is a of n minus 1 that you can write. So if you work it backwards, that would be the reverse one there, right? So omega of n minus 1, it has been delayed, right? So once you are having a delay in that, so that would be omega n. So that would be omega n plus 1 there. So in the previous one. Okay, so you can write it like this, and what you can do here is you can have a of n as the output. So what you can do, that is x of n. Okay, so this comes here, so that is minus 1 by 4 a of n minus 1. I can write it like this. A of n, that would be equal to x of n minus 1 by 4 times a of n minus 1. Okay, so this a of n minus 1 goes here, and you are having this one which is y of n again. Okay, so what you can do here is you are going to have delayed one. Okay, so y of n minus 1 would be there, so you are going to have the delayed function of it. You can write it. Okay, so from here you are going to have the delayed block in the fashion like this, and you can write it as y of n, that would be equal to a of n minus 1 is here, this is here, so this is a of n minus 2 that you can write it. Okay, so y of n would be equal to a of n minus 2 plus 1 by 4 times y of n minus 1. Okay, you can write it like that. Okay, so a of n is equal to x of n minus 1 by 4 a of n minus 1. So you are going to n minus 2. So how did I write a of n minus 1 is there? So this function here, what you can write it is 1 by 4. You can write it as with the positive sign again. So 1 by 4, the delayed version of it. Okay, the delayed version, if you want to write the delayed version, which you can get added up later on, So to get y of n, okay, to get y of n, you are going to have the delayed version of it. Okay, so now what you can write is, you can have a of n minus 1 and n minus 2 equation being formed, and then you can have the final equation being written there. Okay, so what you can do here is, you can carefully analyze the system, and then you can come to know how it is being done, right? So y of n, that would be equal to a of n minus 2 plus 1/4 of y of n minus 1. Okay, or 1/4 of y of n minus 1. So on the other hand, what you can do is, you can have a of n minus 1. Okay, so a of n minus 1, where n is being replaced, so you take this equation, a of n, that would be equal to x of n minus 1 by 4 times a of n minus 1. Now replace n with n minus 1, only n with n minus 1. So what you are going to get? So n with n minus 1, x of n minus 1 minus 1 by 4 a times n minus 1 minus 1. Okay, so that is x of n minus 1 minus 1 by 4 a of n minus 2. Okay, so what you can do here is, you can have a of n minus 1. Now in the similar way, what you can do is, you can have a of n minus 2 being written. So what you can do here, so in case if you want to find out a of n minus 2, okay, so in case if you want to find out a of n minus 2, so you can have this again, you can replace a with this function. I'll be taking it with the n minus 2 being replaced. In case of n, I'll be replacing n minus 2, x of, this is n minus 1, this is n minus 2, x of n minus 2 minus 1 by 4 a times n minus 3 there. So this equation I'm going to take, I'm going to take this equation and I'm going to replace with this one with n minus 1, this one with n minus 2. Okay, so a of n minus 2, that would be equal to x of n minus 2 minus 1 by 4 a times n minus 3. Okay, so now what you can do is, you can have a of n minus 2 that is equal to y of n minus 1 by 4 times that one, and you can have the equation being written like this. Okay, so in the same manner, what you can do there is, you can have this substitution being done carefully. Okay, so this is entirely the substitution problem that you can come across. Okay, so a of n minus 2, that will be equal to x of n minus 2 minus 1 by 4 a times n minus 3. So you have a of n minus 2, that would be equal to y of n minus 1 by 4 y of n minus 1. Okay, next you are going to have a of n minus 3, that would be equal to y of n minus 1 minus 1 by 4 y of n minus 2. Okay, so next what are you going to have? You are going to have y of n. So y of n is being written as x of n minus 2, okay, minus 1 by 4 a times n minus 3, okay, plus 1 by 4 y of n minus 1. Fine. So now what you are going to do here, you are going to replace a of n minus 3. Okay, in order to replace a of n minus 3 here, you are going to have this being replaced here. So a of n minus 3 would be equal to y of n minus 1 minus 1 by 4 y times y of n minus 2. Okay, x of n minus 2 minus 1 by 4 times this function over here, that is y of n minus 1 minus 1 by 4 y of n minus 2 plus 1 by 4 y of n minus 1. Okay, that is y of n. Okay, so there you are going to replace, and you are going to get the equation as y of n minus 1 divided by 16 y of n minus 2, that would be equal to x of n minus 2. So this is the final equation what you are going to get there. Okay, you have to be very careful. So first signal, you have to take a of n, and the delayed version of it is a of n minus 1 and the delayed version what you are going to take from the output. So output is being tapped here. So what you are going to do, you are going to have the one more delayed version of it, that is a of n minus 1, that is being added to the second subsystem what I'm talking here. So that is the second subsystem. I'll show you here. Yes, this is the second subsystem what I'm talking, and this one is the first subsystem. So in case of the second subsystem, what you are going to do, you are going to have a of n minus 1 plus this output what you are going to get plus 1 by 4. So it's a delayed thing, and you are going to add it. So y of n, it would be equal to a times n minus 2. So this one here, that is, it is being delayed by a of n minus 2, and the delayed version of it, it is again a of y of n minus 1. So up to this point here. Okay, so delayed version you are going to get where both the signals are being delayed. So observe carefully. If I have 1 by 4 y of n here, so this is going here. What is the signal here? A of n minus 1 plus 1 by 4 times y of n. So now a of n minus 1 will be a of n minus 2 plus 1 by 4. I think you are very sure about the delay version of it, that is y of n minus 1. So both the signals get delayed equally, right? So if I have a summer or if I have any other block which is there, so once it passes through a delay unit, you are going having it delayed by 1 unit. Okay, so that is what you can observe here. Fine. So hope you can go through certain problems, and we'll have our discussion in such problems in the remaining classes. Okay, so I'll stop sharing now.